Good morning, dear students. Once again, we are here to discuss RDOE Worksheet 67 from your chapter Work and Energy. And today we will discuss concept of kinetic energy. What is kinetic energy? There are different forms of energy in the nature, as we have discussed in our previous worksheet: solar energy, mechanical energy, wind energy, electric energy, right? There are so many forms. The light energy, there's so much sound energy, there's so many forms of energies are there in our nature. When an object possesses energy due to its movement, okay, when an object move and due to its movement, that energy is called as kinetic energy. So an object possesses kinetic energy while it moves. So an object is at rest, does not possess kinetic energy. Those objects which are on rest, they don't have kinetic energy. So examples of the objects having kinetic energy, like running water, means like in river, moving bullet, rolling stone, okay, wind, okay, moving wind. So they are all the examples of kinetic energy. They all possess, kinetic energy. Okay, so what is the definition of kinetic energy? Kinetic energy of an object is defined as the energy possessed by an object due to its motion. Okay, whenever the object is in motion, it possesses an energy which is called as kinetic energy. Kinetic energy of an object depend upon the two factors. First is mass. Mass means the if the object has more mass, then more kinetic energy is there. Whereas velocity, if the object has more velocity, then there is more kinetic energy. Now coming to the mathematical expression for kinetic energy. Let us consider an object of mass m moving with a velocity u displaced to the displacement s. Let us consider an object having the mass m, okay, and when we apply a force and it has initial velocity u. Whenever we apply a force, it moves, okay, it moves or it covers some distance that is included into its displacement, and that force changes its velocity from u to v, because it due to force it got some acceleration. Okay, so when force F is applied acting on it, it produces an acceleration to increase its velocity, as I told you. Therefore the work done is, we know the work done is equal to force into displacement in this case, or according to the second law of motion, we have F is equal to m into a. We put the value of F in this equation, then m a dot s. Okay, and according to the third equation of motion, we have v square minus u square is equal to 2as. Okay, then we have v square minus u square divided by 2a is equal to s, right? Now we have w is equal to m a into v square minus u square divided by 2a. If we put the value of this s in this equation, right, and when we solve it, we cancel out this a is cancel out, and we have half m v square minus u square. And if we consider the object is at rest, so initial velocity will be 0, so u is equal to 0, and if we put the value of u in this equation, we will get half m v square minus 0, that is half m v square. Okay, so work done in terms of energy, we have kinetic energy written like this, half mv square. As we know, the work is nothing but energy is nothing but capacity to do the work. So work done in terms of energy, we will get this equation. Okay, equation of kinetic energy. So with this we conclude that if an object is on rest, means U is equal to 0, then kinetic energy of that object is also 0. Means if an object is on rest, its kinetic energy is 0. Okay, let's do this example. Example first, we have an object of mass 10 kilogram is moving with a velocity of 4 meter per second. Find the kinetic energy. We have to find out the kinetic energy of an object, half mv square. So let's do mass of an object half mv square. We put the value of all these. We have 10 into 4 square. We will get 4 into 4, that is 80 joule if we multiply all these values. Okay, and the unit of energy is joule. Second example, we have calculate the work done. Work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour. Initial we have 30 km per hour. Final we have 60 km per hour. Then if the mass of an object m, we have 1500 kilogram. First of all, we have to convert this kilometer per hour to meter per second. For that, see, they have directly given you to multiply with 5 upon 18. How this 5 upon 18, 5 by 18 comes? See, we have to convert kilometer to meter. For that, we have to multiply it with 1000. And for hour to second, we have to multiply it with 3600. So kilometer per hour, kilometer is converted into meter per second. Okay, so by cancel out this and dividing it with 2, 2 5s are 10 and 2 18 to the 16, we have 5 by 18. So in this, that is why this U, we have 30 kilometer per hour is converted into 30 into 5 by U is equal to U is equal to 30 kilometer per hour and multiply this 30 with 5 by 18. We have, dividing it with 6, we have 25 by 3 meter per second. In second, we have 60 into 5 by 18. So 3, 10, dividing it with by 6, we have 50 divided by 3 meter per second. Okay, so work done, we have work done is equal to what? Change in kinetic energy. And what about kinetic energy? Means that is equal to your final kinetic energy minus initial kinetic energy. So what we will get? W is equal to half m 50 divided by 3 divided by 3 square minus 25 upon 3 square. Okay, so this we have taken as a common, so just 1500. And if we apply the formula of a square minus b square, which is equal to a plus b and a minus b, we will get this 50 divided by 3 plus 25 divided by 3 and also 50 divided by 3 minus 25 divided by 3. So let us solve this. W is equal to half into 1500 and 50 divided by 3 plus 25 divided by 3 and 50 divided by 3 minus 25 divided by 3. We will get half into 1500 into 75 divided by 3 and 25 divided by 3. So if we solve 250, divide this 3 with 75, 25, and again divide this this is 750, okay, and again divide this 3 with this 250. We will get 250 into 25 into 25. If you multiply all these value, means 250 25 into 25, that is 250 into 625. If you multiply these two value, you will get 6250 joule. So this will be your answer. So these are the example. Let's do practice exercise. First question, we have defined the kinetic energy and also write its formula. Kinetic energy of an object is defined as energy possessed by an body or by the virtue of its motion. Its formula is kinetic energy is equal to half mv square. This is the answer of your first question. What would be the kinetic energy of car standing in the garage? 0, because it is not moving. So answer is 0. Answer of second question is 0. On what factor does the kinetic energy of an object depends? Kinetic energy of an object depends upon the mass as well as the velocity. This is the answer of your third question. If in more mass, more kinetic energy is there. More velocity, more kinetic energy is there. Okay. Second, we have 4. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second in 25 joule. What will be the kinetic energy when its velocity is double? Okay, let's do this question. Fourth question, we have see, we are given with velocity 5 meter per second, okay, and second we have energy, kinetic energy, that is 25 joule, and we have to find out the mass. Okay, so let's put the value of all these kinetic energy. We have kinetic energy is equal to half mv square. So here we put 25 is equal to half m, we have to find out, and we have 5 square. So 25, this 2 when transformed here it get multiplied, and m into 25, this 25 when this is multiplied with the m, and when it transformed to the other side it get divided like this. So m is equal to 2 kilogram. Now further we have what is in the question, that what will be the kinetic energy if the velocity is doubled. Okay, first we are given with the velocity 5 meter per second. Now velocity is doubled, so we will get 10 meter per second. Mass we have just find out 2 kilogram. Now new kinetic energy will be half mv square. Then we have half m what 10 v square, we have 5 square. So let me do we have 10 square, okay, and this is we have 2. Okay, let me just put the value in the right way. We have 5 meter per second. We have to double this, so we have to multiply, that is 10 meter per second. Then m we have 2 kilogram. Kinetic energy formula we have mv square. Let's put the value of all this m we have 2. Okay, I have just written 10 by mistaken, so the right one is 2. Okay, that is why I am repeating it. 2, and this v is 10 square. This 2 is cancel out, 10 into 10, that is 100 joule. This is the right answer. Okay, Next question we have, certain force acting on the 20 kg of the mass, okay, changes its velocity from 5 to 2. So the calculate the work done by the force. See, mass we have 20 kilogram and initial velocity we have 5 meter, or you can write v1, 5 meter per second, and final velocity we have 2 meter per second. Okay, so by putting the value of all these, calculate the work done. We know work done is equal to kinetic energy. According to this, we have just studied about this. So work done is equal to half mv square. Half m we have 20, v square we have final minus initial, to v2 square minus v1 square. Let's put all the values in this formula. We will get half m we have 20, v square means 2 square minus 5 square. Okay, so 10 into v square is 4, 25 square is 5 square is 25, then 10 into minus 21, that is minus 210 joule. This is the answer of your question. So this is all about your today's worksheet. I hope you understand it very well. So do like, share with your friends and subscribe the channel. Thank you, bache. Take care. God bless you.